Imagine you're at the scene of an accident. A man's collapsed, he's on the ground. They're going to send an ambulance, but it's going to take way too long to get there. So they send a drone. The drone's carrying a defibrillator, a life-saving device. It flies, it races towards you. It's come into sight. You can see it. It's about to land. Just as it's about to land, a gust of wind strikes the drone and blows it into a tree. My research is aiming to solve this problem by giving drones the ability to measure the flow of the air around them and detect things like gusts of wind so that they can respond. In a conventional airliner, there are hundreds of sensors covering the aeroplane, and there's a human pilot. She has years of experience. She can interpret the data from all these sensors and draw on her knowledge of past experiences and her training of what she should do in a certain situation. And she uses all of this to keep the aeroplane flying safely and land it even in a gust. So we need to come up with a different way that we can put some of these sensors, but we can't afford 100 on a drone. A drone's far too small to have 100 sensors, and there's no way we're putting a human on there. In fact, by definition, it's an unmanned aerial vehicle, so there is no human on the drone. So we needed to come up with another way to solve this problem. We turned to aerodynamics. Aerodynamics is the study of how airflow and objects interact. One aerodynamic behavior that's really interesting to us is called blade flapping. So you can imagine that I'm a propeller, okay? I've got two blades, one here and one here. If there's a gust of wind coming from the audience, as I rotate, one of my blades will be moving into this wind, and the other one will be retreating. The one moving in gets more air rushing over it, so it produces extra lift. The one retreating has less air, so it produces less lift. And this creates an imbalance, so the rotor tilts. And as it rotates, the tilting goes in a cycle over and over again, hence leading to the flapping nature of this. This creates a small force, which we can measure, but existing force sensors, they're not sensitive enough. So we had to create our own force sensors. We took the sensors from a phone that are used to measure air pressure, we embedded them in a specialized rubber, and we placed those sensors into a force sensor that allows us to measure the blade flapping force. And from that, we can compute the velocity of our drone. Okay, so how did it go? Well, we flew our drone around the lab with these sensors on board, and we compared the performance of the $50 sensor to a $40,000 motion capture system, and they were the same. So now we can create drones that can measure the velocity of the wind as it hits them and respond. So when they're flying and coming into land, they get hit by that gust of wind and land safely. Thank you.